Thank you, Dr. Yan, for your comments, and then get some insights into the data resource available in the CDL. And we have about 7 minutes left, and I'm not sure if Dr. McCready, your group is still there?
Yes, we're still here.
Okay, great. Actually, I'm reading the chat room, so there's one question regarding, you're using the SIR model, and then one comment is saying that why not have a missing E, the exposure? So any thoughts, any insights? Your model does not take into the exposure as one compartment.
Yes, so that is that's also a learning lesson. So initially we used the ESIR model because we were really borrowing tools from Peter. And Peter did not consider E compartments. Of course, I did not consider E compartment because Peter has to be a superset of me. Peter is more knowledgeable than me. So, but then we realized that predicting the asymptomatic, so actually the ESIR model, actually the extended SIR model can predict the true number of cases by those latent thetas that we talked about. It's a different strategy to get at the same thing, the asymptomatic or the true number of infections, because you assume them to be latent, and the Y's are realizations that you're observing. But from an epidemiologic perspective, building in testing and the E compartment is actually very important. So Chaolong Wang's work and the Shihong's work on the Sapphire model, which has a pre-symptomatic compartment and a hospitalization compartment into the SCIR model. So our later work actually does consider the E compartment. But both ways, I think we are working on a paper now. How can you compare the number of asymptomatic infections across this different model? That's a very key question to understand. Any other comments from my teammates on this?
I think given the time, I like to leaving the opportunity to the second group. So I was reading the chat room. So there's one question is that you have collected a lot of the data, and then I think is very about this. So there's a comments important besides the disulfiring, the like pathophysiology, epidemiology, pathology, all things. So not sure which data you're referring specific. All those information. So I think Dr. Yan has made comments on the potential use in the kind of a framework. So so I like to either Wendy or Dr. Hu or Dr. Yan, do you guys mind make a comments that your framework go beyond what you have doing? Is any other use cases in your mind that may be useful for using the CDL data resources?
This is Wendy. I'll take it.
Okay.
I think this spatial analysis applies to many different fields, right? If you take the experience of our center here, Center for Geographic Analysis at Harvard, we support research across the university. So public health is only one area. Of course, it's a heavy area. Another heavy area is in urban planning and design. So our design school, a heavy user of this. If you think about smart cities, think about regional planning. There are lots of spatial data assembly, and then modeling, simulation, and then communication with communities. Even though it's not pandemic focused, very much similar process is needed there. And another is environmental studies, climate change, for example, or disaster response. We have collaboration with the Harvard Humanitarian Initiative. You have emergency response. You have crisis mitigation. All these require quick assembly of many heterogeneous data, and then applying geospatial analysis on them. And then also a lot of the data is big data, streaming data, and you have to quickly derive your knowledge to guide the decision making and so on. So pandemic again is only one typical case that we happen to be facing as an imminent threat. Therefore, we use it as an example. But the application of this platform can be applied to anything, economic crisis, for example, right? Where are the labor forces? Where are the supply chains? Where are the business activities? Many different applications can benefit from such a platform. We can hear you, Dr. Xu.
Thank you. I tried to mute myself when you're talking. So actually, I do have questions, and actually, it's a question from chat room. Is that so for India? This is a question for the first group. So if India, if you have a mobile restrictions model for a state with R greater than 1 to the state less than 1, could that be predicted to reducing R in the high R states? It's kind of a something like New York City now. New York State now have a quarantine restriction on a number of the states like in our south part of the country. Is that going to happen? Any effects?
Yeah, so I think that I think the problem in India is actually harder because India is so populous and the disease is now in every state. So even the rural areas are getting infected and they have a very fragile healthcare infrastructure. So my inclination and I think my intuition will be that to say that, in Delhi, for example, I think the borders are closed. They're trying to get this curve down. Delhi R has stayed below 1 for the last 3 weeks, which is incredible because the projections were like Delhi will have very huge peak. So I think that things are working. So the role model is probably going to be that, really learn from the states, increase testing, and centralized quarantine is very key. Because the Indian households are really not good for self-isolation. So once the case is infected, to put it out of the household to prevent household transmission and also cluster transmission, I think extremely important for India. So we have learned a lot from success stories, and I think we need to borrow and adapt those success stories in other states where there is an R above 1. It is not just a question of mobility restriction.
Thank you. This is very important kind of policy recommendation rather than just kind of restriction in those high R states. So I think we're kind of on the top of the hour. So this is a last a webinar. It's based on modeling the COVID-19 pandemic resource methodology applications. And then I would like to really thank you for all the speakers and the discussants. For tonight's a presentation and then also discussions, and also for all the audience, we have at the beginning have more than 200 people participate in today's today's webinar. So thank you all, and then good night, and then stay safe, and then hopefully we will have more publication from your both groups. Okay, thank you very much, and talk to you later. Okay, take care.
Thank you. Thank you, Professor Si.